PIP GenSTEM conversation with Department of General Services and Nancy Whittemore. We're going to turn it over to you in a second, Nancy, but I just want to take a quick second and recognize some of the Metro Council members that we have with us. We have Councilmember Bill Pridemore, we have Councilmember Russ Pulley, we have Councilmember Dave Rosenberg, and Councilmember Tanaka Vercher. And we're happy that they are all here. So thank you very much. Over to you. You got 7 minutes, and we're going to ask you questions.
Okay. Good morning. I'm Nancy Whittemore, Director of General Services and our Sustainability Program. I convened the GenSTEM team to address a need that falls under the Mayor's educational and youth involvement priority areas. Nashville needs a 21st century workforce educated in the core STEM subjects, science, technology, engineering, and math, to continue our prosperity. Our city and county fall in the middle of all other Tennessee counties, and nationally our state ranks in the bottom third of STEM education. Nashville also needs a next generation education in sustainability to become a sustainable city of the future. This need is also our opportunity. Our approach is to integrate sustainability into STEM units using technology to promote active engagement through education in middle schools, grades 5 through 8. We call our solution GenSTEMs, combining the generation that includes tech-savvy children from 10 years to 13-year-olds with STEM curriculum units based on practical sustainability themes. Our team starts with a collaboration of these Metro departments. The first external partner is Vanderbilt University Department of Electrical Engineering and Computer Science and their Institute for Software Integrated Systems. Yonder Interactive, whose expertise is sustainability education, is our other external partner. Yonder created Socket Unplugged Nashville General Services Sustainability website. We begin with Vanderbilt's contribution to our approach.
Good morning. I'm Gautham Biswas, Professor of Computer Science at Vanderbilt University. Underlying GenSTEMs will be a powerful learning environment called CT-SIM, standing for Computational Thinking Using Simulation and Modeling, developed by my research team. Computational thinking describes an approach for formulating computational models in many domains, such as STEM, ecology, and economics, to aid problem solving using computers. This concept links very well with President Obama's Computer Science for All initiative. Here are some prototype screens from CT-SIM, where students learn by modeling, an approach compatible with next-generation science standards that include learning by representation, learning by construction, reasoning, critical thinking, and solving real-world problems. Here's an initial idea of how GenSTEMs may be used to teach sustainability. Students build a vehicle model by applying their knowledge of physics that captures their drive to and from school, and how speeding up and slowing down are related to gas consumption. By linking driving behavior to fuel consumption, a limited resource, they study sustainability. Similarly, car emissions can be used or linked to the greenhouse effect. Mining data from GenSTEMs will be an added benefit for students and their teachers. Derived student performance and behavior can give feedback to students with difficulties. Information about the class and individuals made available to teachers in real time will help them with their instruction. So here is how we will actively engage middle school children and teachers through educational technology.
I'm Bill Giles, the CEO of Yonder. We specialize in interactive sustainability education. We created Socket Unplugged Nashville, the sustainability program for the Department of General Services. We've also created sustainability programs for higher ed, as well as the games for the children's program on Socket. These simple games for 5 to 8-year-olds took coders, writers, designers, educators, and months of research and testing to ensure that there was learning and fun. So what do we know about actively engaging 10 to 13-year-olds for educational goals? We know, next slide. We know that you must be digitally accessible whenever and in whatever way they choose. GenSTEMs must actively engage 10 to 13-year-olds who are part of a generation being labeled Generation Z. This generation was born with smart devices in their hands. 40% of them spend 1 to 3 hours a day on their device, and 35% spend between 6 and 10 hours a day. Now let's put this generation and GenSTEMs together.
Hi, I'm Chris Gowan, CTO of Yonder. I'm going to provide some insight into the GenSTEM's development process. With input from Metro collaborators, the Vanderbilt team will program sustainability content into the curriculum unit for each STEM project. Yonder then takes a curriculum unit and develops widely accessible technology that will prompt active engagement and put a GenSTEM's app in the hands of kids anytime and anywhere. This means researching and creating an intuitive interface similar to the media fifth grade students utilize every day. Here, Yonder would apply our expertise in video, interactive, children's games, and apps from the Socket program to the curriculum units. GenSTEMs will add a major component to General Services Socket Sustainability Program. This is our timetable. With a go-ahead by June, the fifth grade pilot program will begin at the start of the 2017 school year. The pilot will be held in classes that total approximately 100 students. Sixth grade will be piloted in 2018, seventh grade in 2019, and middle school will be completed by 2020 at a cost of $1.325 million over 4 years.
Our approach has enthusiastic support within Metro. These key partners will engage in building the program. Kent Oliver, Director of Nashville Public Library, Chris Henson, Interim Director of Nashville Public Schools, Keith Durbin, Director and CIO for Metro Information Technology Services. GenSTEMs will deliver benefits for the Mayor's Smart Cities initiative, funding for state and federal programs, and support for the ongoing Socket program. But the real contribution will be educating a 21st century workforce for a sustainable Nashville. Thank you so much for this opportunity.
Question on your slide that talked about kids impacted. Your first expectation was 100 children. What does that look like over time? And are those the same kids or those kids that are in this? Somebody needs to go to the mic.
So the idea is to start with a new grade every year. The first year we will start with the fifth grade, about 100 kids. Then move on to a new set of 100 kids in this.
Where do these 100 kids come from?
They come from Metro schools. So for example, we already run studies at Meigs and West End Middle with this system. Not in the polished form that we are thinking of developing, but we already do that right now. And the idea is as we move on from year to year, we introduce it in a new grade with about 100 kids, but then if you're successful in the previous year's program, then we expand that program. So in the second year, we might then expand to more than 100 kids in the fifth grade. This will require some teacher training, professional development.
Is that in here?
It is included in our budget.
Panelists.
We know we have integrated computers into the music programs in the schools.
Yes.
We know that from independent research studies that students that take music, SAT scores go up, regardless of what career they go into, graduation rates go up. Have you considered using music technology in your program and making it STEM to STEAM?
We could, unfortunately, I'm not the music expert. I know a lot of engineering and I know a lot of science, and that's why I have focused in these areas. As this program grows, it would not be difficult to get in people from other disciplines to work with us on these systems. The idea of computational thinking is very broad. As I mentioned earlier, it can be applied to any domain where you're thinking of that domain computationally, and because you're thinking of it computationally, you can then apply it or build computer programs to solve problems in that particular domain, or even be inventive if you want.
Because those students are currently producing and engineering music online.
Yes,
and,
yes.
Using math skills and...
Exactly. So they would be able to combine these skills and probably be quite innovative and inventive in the sense that they could, come up with their own music and then get feedback as to how well it sounds or how well others react to it.
So is this in addition to regular curriculum that is already in our school system? Is this additional after-school programming? How does this fit in? I mean, I know that teachers will tell me already that I already have way too much I got to teach. I don't have time to add something else.
So our goal, and this is funded by the National Science Foundation, has been to integrate it into classrooms. For example, I should also mention that just a few months ago, a teacher in Chicago used our units to teach in a classroom. We were not present in the classroom. So our goal is to get teachers comfortable with this system so that they can use it as part of their instruction. And we've been quite successful doing that.
So if it's already been created by the Nashville or the National Science Academy and it's already being taught in Chicago,
and Nashville.
Why do you guys need the money?
Well, we are researchers, so I have not built a system that can be run in, say, 50 schools at once. It does not have the polish that, say, you could to attract kids. Now, we work in a small number of schools, and the teachers are very enthusiastic, and so they can get kids involved, and it has very great benefits. But if you really want it to be used, say, in the metro school system, there is more that needs to be done right there. You have to build a more polished, more robust system. You have to get teachers trained, because unless teachers buy in, technology doesn't work.
Michael.
Your proposal indicates that there's streams of funding that also include state, federal, private grants, corporate, and NGO. Could you give us a status report on the additional funding that would come to this beyond Metro?
I'll take that. We believe that the money that we put in for will initially get us going. We're hoping that we can apply for grants, state, federal, there's various sources. The other possibility here is sponsorships by private concerns to support this.
Have you done any work on that yet?
Not yet, but our company has some experience in that. So we think this is something that would be very appealing to someone in the community or nationally to get behind.
Talia.
I have a question about the underserved.
Yeah.
And what's in your model to make sure that there are populations out there that wouldn't miss out on this? Because we've heard presentations about digital divides and what have you, and for children that don't have access to devices. How do we address that population?
We have not formally addressed it because, being a researcher, I couldn't come and say, yeah, we've done it because I saw 20, kids using it. We do research, we have to collect data, analyze it, so we haven't done that formally. But certainly there are aspects of the system you can see would be very appealing to, underserved communities, because the problems that they're building the models for and learning the science from is very related to, to problems that they encounter every day in their communities. So for example, the example I gave about learning physics by modeling cars and your drive to school, that's something that every kid can relate to. They see streets being congested every day and how much time they waste, say, when waiting to be dropped off and waiting to be picked up. So we naturally see that kids are motivated motivated to build these models and then try what-if solutions. For example, what if we did this versus that? And I think that same ideas could be passed down, to underserved schools. The other thing I'd like to say is with Nashville going digital, because of all these, the high-speed networks coming in, right, and say Google Fiber promising that low-cost housing is going to get internet service for free, these programs can be downloaded off the web and run at home. So once people start having computing devices at home, right, they could actually play with these systems at home too.
Thank you so much. We appreciate you all being here. Thank you.